Welcome to the Micro Motion How-To video series. In this video, we will cover how to characterize and configure a Micro Motion Coriolis meter. Using the Model 5700 transmitter display, the learning objectives are the following. Know how to check the meter status. Understand how to characterize the meter. Know how to configure the outputs. Know how to save the characterization and configuration. For the complete set of configuration instructions, please refer to the Micro Motion Transmitter Configuration and Use Manual. First, wait approximately 10 seconds for the power-up sequence to complete. Immediately after power-up, the transmitter runs through diagnostic routines and checks for error conditions. Second, check the status LED on the transmitter and use the following table to determine the device status. The ideal LED status is solid green, which indicates that no alerts are active. If necessary, check the active alerts using the display. The display of the 5700 transmitter will show the alert code, along with an explanation for the alert and the course of action. Characterizing the meter adjusts the meter electronics to match the unique traits of the sensor it is paired with. The characterization parameters describe the sensor's sensitivity to flow, density, and temperature. Depending on your sensor type, different parameters are required. Values for your sensor are provided by Micro Motion on the sensor tag or the calibration certificate. If your transmitter was ordered with a sensor, it was characterized at the factory. However, you should still verify the characterization parameters. First, record the following calibration and characterization parameters from the sensor tag or calibration sheet. K1, K2, D1, D2, FCF, DTC, or sometimes labeled as DT and FD. Second, using the display, select Menu, Configuration, Sensor Parameters. Third, confirm your sensor type. Straight tube meter or curved tube, which would be all sensors except a straight tube meter. Fourth, set the flow calibration factor, also known as FCF or flow cal factor. Be sure to include all decimal points. Fifth, set the characterization parameters D1, D2, K1, K2, DT, and FD as necessary, and apply changes for each parameter that has been changed. The sensor works equally well with flow in either direction. The sensor flow direction arrow establishes a convention of forward flow to accommodate customers who need to be able to define forward and reverse flow for process purposes. The sensor flow direction arrow interacts with milliamp outputs, frequency outputs, and totalizer direction to control how flow is reported by the outputs and accumulated by the totalizers and inventories. Using the display on the 5700 transmitters, select Menu, Configuration, Process Measurement, Flow Variables, Flow Direction. Configure the units for mass flow, volume flow, density, and temperature using the following procedures. For configuring mass flow units, use the display by selecting Menu, Configuration, Process Measurement, Flow Variables, Mass Flow Settings, Units. For configuring volume flow units, use the display by selecting Menu, Configuration, Process Measurement, Flow Variables, Volume Flow Settings. For configuring density units, use the display by selecting Menu, Configuration, Process Measurement, Density, Units. For configuring temperature units, use the display by selecting Menu, Configuration, Process Measurement, Temperature, Units. Mass flow cutoff specifies the lowest mass flow rate that will be reported as measured. All mass flow rates below this cutoff will be reported as 0. The same definition can be used for volume flow cutoff. Refer to your specific transmitter configuration and use manual for proper cutoff value. For configuring mass flow cutoff, use the display and select Menu, Configuration, Process Measurement, Flow Variables, Mass Flow Settings, Low Flow Cutoff. The milliamp outputs are used to report current values of process variables. The milliamp signal varies between 4 milliamps and 20 milliamps in proportion to the current value of the assigned process variable. First, configure the milliamp output by using the display and select Menu, Configuration, Inputs, Outputs, Channel, I/O Settings, Source. For example, the milliamp source can be set as mass flow rate, volume rate, temperature, density, or drive gain. Second, configure the range for the milliamp output by selecting lower range value or 4 milliamp signal and upper range value or 20 milliamp signal. Scale the frequency output to provide the data in the form required by the device that is receiving the transmitter frequency. This can be completed by using the display and selecting Menu, Configuration, Inputs, Outputs, Channel, Frequency Output, I/O Settings, Scaling Method. To save the current configuration to a USB drive as either a backup file or a replication file, first, open the wiring compartment on the transmitter and insert a USB drive into the service port. Choose Menu, USB Options, Transmitter, USB Drive, Save Configuration File, Save Active Config to USB Drive. Second, choose Backup or Replicate on the display screen. Backup files contain all parameters. They are used to restore the current device if required. The spare extension is used to identify backup files. Replication files contain all parameters except the device-specific parameters, for example, calibration factors or meter factors. They are used to replicate the transmitter configuration to other devices. This concludes the how-to video of Coriolis meter characterization and configuration. In summary, when using the Model 5700 transmitter display, you should now know the following. Know how to check the meter status. Understand how to characterize the meter. Know how to configure the outputs. Know how to save the characterization and configuration. For the complete set of configuration instructions, please refer to the Micro Motion Transmitter Configuration and Use Manual, which can be found on www.emerson.com.